Alright, so for today's video lesson, we're going to do topic 4.4b. This is simplifying algebraic expressions involving radicals. Okay, so last day's lesson, we were graphing radical equations and expressions. Okay, so this is the second half of that topic. Alright, so our first example here, and again, remember we are simplifying algebraic expressions involving radicals, okay? Now when we're doing this, we have to first look at our expression and find any restrictions on the variable, and then we want to write it in simplest form. Okay, so for 1a, so we have the square root of x, okay? So this is the same thing as saying the square root of x to the 1. Now, when we are finding restrictions, we do need to take note of the degree of the exponent, okay? So if it is an odd exponent, then we need to have a positive value for x. Okay, because we cannot take the square root of a negative number, okay? We cannot do that. Okay, so if we have an odd exponent, we need to have a positive value for x. Or we could also say that x must be greater than or equal to 0. Okay, if we have an even exponent, there are going to be no restrictions. Right? Because if we have an even exponent, if our x value is -4, -4 times -4 will give us 16, which we can take the square root of, right? That's a positive number. Okay, but if it is an odd exponent, we need to have a positive value for x. Because if it's like -6 just to the 1, if our x was -6 to the 1, then if we're trying to take the square root of x, we're trying to take the square root of -6, which we cannot do. Okay? So that's important. If we have an odd exponent, we need to have a positive value for x, or x needs to be greater than or equal to 0. Okay, it can be equal to 0 because the square root of 0 is just 0. Okay? So for our first one here, so the square root of x, the only restrictions here is that x must be greater than or equal to 0. And again, we have an odd exponent here, so our restriction is that our x must be positive. Okay? For b here, so b we have the square root of x squared. Okay? Now we have an even exponent, so we do not have any restrictions. Okay, so now we just need to go ahead and simplify this, okay? So to get x squared, it is going to be x times x. Now if we have remember, if we have a pair when we're taking the square root of something, we can just take this that number outside. So the square root of x times x is going to be x. Okay, so that is x is x squared, the square root of x squared simplified. Okay, and our restrictions, because it is an even exponent, we do not have any. Okay. So for these questions, so first we need to analyze the degree of our exponents. So for x to the cubed, x to the 3, this is odd exponent. Therefore, x must be greater than or equal to 0, right? If we have a negative value for x, once we cube it, it will still be negative, and we cannot take the square root of a negative number, okay? So we stated our restrictions. Now let's let's simplify this x cubed, okay? So to get to x cubed is the same as multiplying x by x by x. Okay, we're taking the square root, so we're going to look for a pair. So right here we have two x's, so let's take those outside. So we get x root x is our fully simplified, and we have stated our restrictions right here. All right, so for D, we have the square root of x to the 4. This as an even exponent. Therefore, we have no restrictions on x. Okay, so now we can just go ahead and start simplifying this. Okay, so how do we get to x4? Well, we can multiply x by itself 4 times. Now, again, we see two pairs here. So let's do these one at a time, okay? So let's take out this first pair of x's. We get x square root of x times x. And then we have another pair, so let's take those outside. And then x times x gives us x squared. Okay, so no restrictions, and our fully simplified radical is x squared there. All right, so example 2, these are involving adding and subtracting radicals. So remember, to add radicals, we need to have the same radicand, right? So in this case, we both have root x as our radicand, so we can add those together. And same within B, we have the same radicand, so those can also be combined, right? They have the same radicand. Okay, so first let's state our restrictions. So we have an odd exponent, therefore x must be greater than or equal to 0. Okay, so now that we have stated our restrictions, let's go ahead and start simplifying this. So root x is the same thing as 1 root x plus 5 root x. Because we have the same radicand, we can just add the numbers out in front. So this becomes 6 root x. And our restrictions are x must be greater than or equal to 0. Okay, on to B. So we have 2 root 4x to the 4th minus 8x to the 4th. So I think I actually said that we had the same radicand just a moment ago, but we actually don't, right? 4x to the 4 is definitely different than 8x to the 4. Okay, so we cannot just subtract those right off the hop. Okay, so we need to simplify those a little bit so we can clean this up. First, let's state the restrictions. So we have an even exponent, therefore no restrictions. Okay, so let's go ahead and simplify this. So how do we get 4x to the 4? Okay, how do we get that? So let's leave our 2 out front, and we'll leave that alone. And then to get to 4x4, we could do 2 times 2 will give us 4. And then x squared times x squared will give us x to the 4th, right? Minus, how do we get 8x to the 4? Well, if I do 2 times 2 times 2 is equal to 8, multiplied by x squared, multiplied by x squared, right? 2 times 2 is 4, times x squared is 4x to the 4th, minus 2 times 2 times 2 is 8, times x squared is 8x to the 4th. Okay, so again, we have a square root, so let's find some pairs. So I see pairs there, and we also have a few pairs over here, okay? So let's unpack this. So we'll take those 2 and the x squareds out. So 2 times 2 is 4, times x squared gives me 4x squared, minus, let's take those 2's and the x squareds out. So we'll have minus 2x squared root 2. Okay, and we have no restrictions on our x here. So if we wanted to do like a domain, kind of like what we saw yesterday, x is going to be a set of the real numbers. Okay, it can be any value. All right, motoring along. So example 3, this is where we're just going to be simplifying. Okay, so again, we do need to first state any restrictions on the variable and then simplify this. Okay, so for root 18x cubed, we have an odd exponent. Therefore, x must be greater than or equal to 0. Okay, so now that we've stated our restrictions, let's go ahead and simplify this. So let's leave the 4 alone for the meantime. And how do we get to 18? Okay, that one might be a little bit more difficult to see. So to get to 18, we do 2 times 9 and 3 times 3. So 18 becomes 2 times 3 times 3. And how do we get x cubed? X times x times x. Okay, so let's look for some pairs. I see we have 2 3s and 2 x's, so we can bring those outside. So 4 times 3 is 12. Multiplied by x is 12x. And what's left behind is 2x. Okay, and our restrictions, x must be greater than or equal to 0. R is for restrictions, not to be confused with range. Okay, so on to the next one, negative 7y squared root 8y to the 5th. We have an odd exponent again, so therefore my restrictions are going to be x must be greater than or equal to 0, because we have an odd exponent underneath the radical. Okay, so let's go ahead and simplify this. So let's leave our negative 7y squared alone. And how do we get to 8y to the 5th? Okay, so to get to 8, we can do 2 times 2 times 2. And to get y to the 5th, you can either do y times y times y times y times y, or you could also do x or y squared multiplied by y squared multiplied by y. Okay, again, let's look for some pairs. So I have 2 2's and 2y squared, so let's take those outside. So negative 7 times 2 is negative 14. And then y squared times y squared gives me y to the 4th. And what is left underneath the root is 2y. All right. Now, for this one here, we need to be a little bit more cautious when we're doing our restrictions, okay? Now, remember, we cannot take the square root of a negative number, okay? So, we need to set our radicand greater than or equal to 0. And see what values of x will satisfy this equation, which will not give us a negative number. Okay, so let's set the radicand greater than or equal to 0. So x minus 5 is greater than or equal to 0. Okay, so let's solve which values of x will ensure that we have a positive radicand. So we'll add 5 to both sides, and we find here that x is greater than or equal to 5. Okay, so anything less than 5, so if x is equal to 4, 4 minus 5 gives us negative 1, which we cannot take the square root of. Okay, so our restrictions our x must be greater than or equal to 5. Okay, and root x minus 5, we cannot simplify this any further. So this is our fully simplified answer, x minus 5. Okay, the big thing here in this question is to make sure that we are solving for those values of x that will ensure that we have a positive radicand. Okay, so in this question, our restrictions is that x must be greater than or equal to 5. All right, so now we'll get into some multiplying here. So with these brackets, we just need to multiply them, like you guys have seen before. Now remember, when we are multiplying radicands, we need to multiply the number in front of the radicals, and we also need to multiply our radicands together, okay? So, 5 multiplied by negative 2x gives me negative 10x, and root, so 6x squared multiplied by 2 gives me 12x squared. Okay, we can go ahead and simplify this, but before we do that, let's state our restrictions first. Okay, we have a even exponent. Therefore, no restrictions. So, x is a set of the real numbers. Okay, and let's go ahead and simplify this now. So let's leave our negative 10x alone. And how do we get to 12? 2 times 6, and to get to 6 it is 2 times 3. So 12 will become 2 times 2 times 3, and x squared will become x times x. Okay, again we are looking for pairs. So I see a couple. So let's bring those outside. So negative 10 times 2 is negative 20. And x times x is x squared. And what's left underneath the root is root 3. All right. Moving on. Okay, so this one we have 2 terms within the brackets, so we need to distribute that negative 3 root x to both terms. Okay, and same thing like we did in the last example, we want to multiply the number in front of the radicals, and then we'll also multiply the numbers underneath the radicals. Okay, so negative 3 times 2 is negative 6, and root x multiplied by root 2 gives me root 2x. Now my second term, so we're minusing. Let me get rid of that bracket. Okay, so we have negative 6 root 2. Okay, now we're going to multiply negative 3 by negative 3x will give me positive 9x. And then we also need to multiply the radicand. Under here you can just assume it is root 1. So it'll be 9x root x. Okay, to simplify this any further, we need to have the same radicand. Okay, we do not. We have 2x and x. So this is as good as it gets. This is our final answer. And restrictions on this function, we have an odd exponent. So therefore our restrictions, x must be greater than or equal to 0. And our fully simplified answer is right here. I know it may not look like it, but it is. Okay? And again, remember we need to have the same radicand to simplify that. Okay, this one here, we have two terms in the first bracket, and we also have two terms in the second bracket. So we need to distribute that to each term, right? This is our FOIL. So first, outside, inside, last, right? And just like we're doing in the last couple examples, we'll multiply the number in front of the radicand. So here we get 10 times 5, which is, 2 times 5, which is equal to 10, and root x, minus 3 times 2 is 6, and then root x multiplied by root x gives me root x squared. Okay, for the second term here, so 3 multiplied by 5 is positive 15, and then 3 multiplied by negative 3 root x gives me negative 9 root x. Okay, we can simplify this a little bit. Okay, so we have a root x and a root x. So 10 minus 9 just leave me with root x minus 6 x squared plus 15. Okay, so we need to simplify this to reveal what our restrictions will be. Okay, so root x, we're just going to leave that one alone, not much we can do there. Minus 6, to get x squared we have x times x plus 15. Okay, so if we have x times x, that's a pair, we can take those outside. So we get root x minus 6x plus 15. Now, at this point, we need to analyze our restrictions, okay? So what are our restrictions? We have an x to the 1 underneath the root. So odd exponent, therefore x must be greater than or equal to 0. That's our restrictions. And that is our fully simplified radical. All right. Couple more examples to go. 2, to be exact. Oops, wrong way. Okay, so example 5, this is where we are dividing. So same thing here, we need to state any restrictions on the variable and then simplify each expression, okay? Now if you're asking yourself, when do we state the restrictions on the variable? That is a good question. If it's in a rational function like we see here, rational just means that it's dividing, right? In that case, we need to analyze it here because we cannot have a 0 in the denominator, okay? That will give us an undefined function. Okay, so also when we have a numerator and a denominator, a rational function, we need to analyze the restrictions on them separately, okay? So for the numerator, it is 15 root x cubed. This is an odd exponent, so therefore x must be greater than or equal to 0, okay? I'm just going to draw it on a number line here because it might help us piece this problem together, okay? So this is 0. So for my numerator, it has to be greater than or equal to 0, okay? So these are conditions that are true for only my numerator. Okay, for my denominator, negative 3 root x squared. We have an even exponent, therefore no restrictions on x. Okay, however, our denominator cannot equal 0, right? except that it cannot equal 0. So what values of x will cause my denominator to be equal to 0? Well, if x is equal to 0, the square root of 0 is 0, and multiplied by negative 3 is still 0. So x cannot equal 0, okay? But it can be any other number, just not 0. So how we write that on a number line? So we're going to have an open circle where 0 is, okay? Because it does not include that point. And if it can be any value to the left or right of that, just not 0. Okay, so that's what that little open dot on there represents, okay? And now for our restrictions, we need to ask ourselves, where do they both agree? Okay, if we are less than 0, only the denominator is happy, right? If we are at 0, only the numerator is happy. However, if we are past 0, they both agree, right? So therefore, our restrictions, x must be greater than 0. Okay? If it is 0, it will make the denominator equal to 0, which is undefined. Okay? So x cannot equal 0, and they both agree when x is greater than 0. So those are our restrictions. Okay, so just be careful. Okay, so when we're dividing rational functions, we need to make sure that the restrictions agree with one another for them to be the restrictions for the function. Okay, so we've just found our restrictions. Let's go ahead and simplify this now. Okay, so 15 root x to the 3 divided by negative 3x squared is the same thing as saying 15 divided by negative 3 multiplied by root x, x cubed divided by x squared. Now remember from a couple topics ago, when we're subtracting or when we're dividing exponents, we are subtracting exponents. So we're going to subtract the numerator or the denominator exponent from the numerator. So it's going to be x to the 3 minus 2, right? We are subtracting our exponents when we are dividing them. Okay, so 15 divided by negative 3 is negative 5, and the square root of x to 3 minus 2 just leaves me x to the 1. Okay, so we can just fully simplify that as negative 5 root x as our fully simplified function. And our restrictions are that x must be greater than 0. All right, one more example for today. So another division one. And again, it is important that we need to check the restrictions for both the numerator and the denominator separately. Okay, so for the top, we have an odd exponent. Therefore, x must be greater than or equal to 0. So again, let's write this on a number line just to help us visualize the restrictions on this function. Okay, so for our numerator, x must be greater than or equal to 0. So we have a closed dot on 0 because 0 is included in that. Okay, and for the denominator, 2 root x, it also has an odd exponent. So x also must be greater than or equal to 0. Okay? Now let's check what values will make this function undefined. So if x is equal to 0, square root of 0 is 0, multiplied by 2 is 0. So x cannot equal 0. X must be greater than or equal to 0, but it cannot equal 0. Therefore, x has to be greater than 0. So we're going to have an open dot on 0 again. And that is going to the right. Now, we need to ask ourselves, where do they both agree? So they're both on 0, but only one of them does not include 0. So our restrictions, x must be greater than 0. That is where they both agree. Okay, so let's go ahead and simplify this now. So we have 6 root 5 minus 2 root 24 x cubed divided by 2 root x. Okay, because 5 does not divide evenly into x, we should rationalize our denominator here first. Okay, so we're going to multiply this by the rational in the denominator, which is root x. So multiply by root x over root x. Okay, this will then look like, so we're going to multiply that by both terms, right? So we will have 6 root 5x minus 2 root 24 x to the 4th over 2 times x, which is going to be x squared. Okay, so now I'm just going to rewrite this one more time. Just get rid of those x squared. So we have 6 root 5x minus 2 24 x to the 4th all over 2 root x squared. Okay, so now let's go ahead and simplify now that we're at this point. 5x is pretty much as simplified as we can get, but we can simplify our 24x. So how do we get to 24? We have 2 times 12, 2 times 6, 2 times 3. So let's rewrite this over here. So we have 6 root 5x minus 2. And our 24 becomes 2 times 2 times 2 times 3. And then we have an x to the 4. How do we get there? X squared times x squared. And that is all divided by 2 root x squared, which will be x times x. So we can simplify that to be over 2x. Okay, let's look for pairs here. So we have 2 2's and 2x squareds. So we have 6 root 5x minus 2 times 2 is 4, and multiplied by x squared is x squared. And what's left in there? We have a 2 and a 3, so root 6 divided by 2x. Okay, we can simplify or we can reduce this fraction. Okay, so 6 divided by 2x, so we get, that will become a 3 root 5x minus 4 divided by 2 is 2. And we're just going to leave the x's alone. Otherwise, we will have confusions with our first term there, divided by 2x. And that should just be an x because we divided that, right? 6 divided by 2 is 3 over 1. Okay, so here is our fully simplified radical, and we have described our restrictions at the top. X must be greater than 0. Okay, so just in summary of what we have learned in this topic. So when working with an algebraic expression involving radicals, we need to state restrictions on the variable. Okay, so if we're taking the square root of something, we cannot take the square root of a negative number. Okay? So the square root of all powers with an even exponent is defined for all values of x. So there are no restrictions when we have an even exponent. But when we have an odd exponent, such as root x or root x cubed, our values for x must be greater than or equal to 0, okay? And this is where x is a set of the real numbers. The symbol, or the square root symbol, indicates the principal square root, which is always positive. Remember, when you take the square root of 16, you'll get positive and negative 4. The principal square root is 4, okay? The secondary square root would be the negative 4. The square root of x squared must equal the absolute value of x. Okay, so if you're just taking the square root of x squared, you'll just get x, right? And when you are simplifying, adding, subtracting, or multiplying, or dividing algebraic expressions, we need to use the same principles used for numerical expressions with radicals. Okay, just a reminder, if the radicands have the, if we have the same radicand, the same value underneath the square root, we can add up the coefficients in front, okay? And we can simplify using multiple mathematical properties by distributing and also by, remember this was radicalizing the denominator. Okay? So for the remainder of today's class, I would like you to work on these practice problems, please. Once you have completed the notes and the assignment, please take the time to submit those to the classroom or send me an email. Okay, so this is a 37-minute video. So I would expect you guys to be working on these for at least 15 minutes. Okay, on Monday, you guys are going to have a 4.4 take-home quiz. Okay, so yeah, if you have questions or you need help with anything, please reach out. And I hope you have a lovely weekend.